Hello there, and welcome. Tonight, we'll drift into a substance so familiar it hides its own miracles: water. It builds clouds, fuels storms, sculpts coastlines, and fills your every cell. Yet, it also defies logic, expanding when it freezes, dancing upward in trees, and whispering through the air as invisible vapor. Every glass you drink contains atoms older than the sun. Every ocean wave echoes chemistry born in the stars. Together, we'll explore 100 facts that reveal water not just as a liquid, but as a language, one that speaks through tides, raindrops, and the pulse beneath your skin. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or press the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Water is simple, yet impossible. 2 atoms of hydrogen, 1 of oxygen, an arrangement so ordinary it feels like it should be predictable. And yet, it is one of the strangest substances known to science. Almost everything else in the universe behaves according to clear, sensible rules. When something cools, it contracts. When it heats, it expands. But water refuses. As it nears freezing, instead of shrinking tighter, it blooms, expanding like a living thing. Ice floats not because it is lighter, but because its molecules arrange themselves into a crystalline lattice, open and airy, full of space. That small act of rebellion keeps entire worlds alive. Lakes freeze from the top down instead of the bottom up, sheltering fish and plants in liquid beneath. Without that inversion, winter would mean extinction. The surface would lock solid, the cold would deepen, and every drop of life would be trapped in a frozen tomb. Each molecule is shaped like a tiny boomerang, a bent letter V with a negative charge at its tip and a positive charge at its arms. Those charges pull at each other like invisible magnets, linking and breaking in endless motion. A single cup of water contains more bonds forming and dissolving in 1 second than there are stars in the Milky Way. This constant dance gives water its fluid grace, its ability to cling, to rise, to shape. It makes droplets bead on leaves, streams cling to rock, and oceans roll with soft, sculpting hands that can wear down mountains. If you could look close enough, deeper than any microscope allows, you would see water as a restless network of shifting geometry. Molecules slide and rearrange, never quite settling, always exchanging partners. It is this transience that makes it the great dissolver. Nearly everything that touches it, salt, sugar, minerals, even air, finds itself undone. When you stir a spoonful of salt into warm water, it doesn't simply disappear. The water pulls the salt apart ion by ion, surrounding each fragment with cages of molecules, holding them apart like peacekeepers. It is chemistry as empathy, one substance breaking another's isolation, turning hardness into harmony. And yet, that same softness can carve stone. Rivers slice through granite not by force but by persistence, carrying fragments grain by grain until entire valleys are born. Over ages, droplets gather into torrents, torrents into floods, and the planet itself yields. The Grand Canyon, the cliffs of Ireland, the hidden caves of Thailand, all are signatures of water's patience. It does not rage, it whispers. It persuades the solid to remember that even rock can flow, given enough time. Temperature, too, plays tricks within it. Heat it slightly, and it rises in graceful plumes of vapor. Cool it, and it becomes glassy and rigid. Between those states lies an entire spectrum of mystery: supercooled water that remains liquid below freezing, water that briefly exists in multiple phases at once, droplets that levitate on cushions of vapor when poured on a hot surface. No other common substance changes its form with such elegance or ease. It defies definition, not just liquid, solid, or gas, but a continuum shifting from one identity to another, like an actor in constant transformation. Even its sound is deceptive. The gentle rush of a stream, the steady patter of rain, the muted thud of snow, all are created by the same molecules, vibrating at different speeds, striking and separating, composing symphonies of motion. Each tone tells a story of temperature, pressure, and shape. A waterfall doesn't roar because it is violent, but because billions of tiny bubbles collapse and reform in the blink of an eye, releasing bursts of trapped air that our ears translate into thunder. Scientists once assumed they understood water. After all, it's everywhere, an open book in every glass and every cloud. But even now, its secrets resist simplicity. Why does it have such an unusually high surface tension? Why does it absorb heat so effectively that oceans can buffer an entire planet's climate? Why do its molecules align in liquid crystals under certain conditions, behaving more like living tissue than chemistry? The deeper we look, the stranger it becomes. Water bends light, bends heat, bends the laws we think we know. It flows uphill through trees, defying gravity by clinging to the narrow capillaries in their xylem, rising hundreds of feet in silence. It hovers at the edge of existence in clouds, each droplet a fragment of sky waiting for a reason to fall. It balances between chaos and order, binding atoms and lives together, then releasing them again. And yet, for all its complexity, water remains humble. It asks for nothing. It mirrors everything. A still lake reflects the world because its molecules are so cooperative, aligning perfectly under calm. When wind disturbs it, those bonds break and scatter the image, fracturing sky and forest into ripples of light. What we call reflection is simply the dance between structure and surrender, between order and motion. Every breath you take owes itself to water's contradictions. It carries heat from the equator to the poles, softens the climate that nurtures forests and fields, and gives rise to storms that renew the land. It is the only substance that can exist naturally on Earth in all three states, at once ice, liquid, vapor, bridging air, land, and sea. In every state, it writes a new chapter of the same story, that strength can come from fluidity, that power can live inside surrender. To understand water is to glimpse the hidden flexibility of the universe itself. Nothing else holds so much paradox within such simplicity. It is at once fragile and indestructible, yielding and unyielding, familiar and alien. It is the quiet riddle running beneath every wave and heartbeat, whispering that the most common thing in the world is also the most extraordinary. Long before there were rivers or rain, before Earth even had a sky to hold them, water began its story in the dark silence of the early universe. After the Big Bang, when space was still thick with heat and newborn energy, only the simplest elements existed: hydrogen first, then helium. The cosmos was a sea of invisible fire, too young for anything like oceans. But in time, stars began to form from those primal gases, igniting like lanterns in a vast and restless night. Within their hearts, under unimaginable pressure, something miraculous happened. Hydrogen fused into helium, helium into heavier elements, and with each generation of stars, the ingredients for water slowly came to be. Oxygen was one of the rarest gifts of those stars, born in their final moments. When massive suns burned through the last of their fuel, they exploded in supernovas so powerful they could scatter atoms across light years. Those blasts seeded the universe with oxygen, carbon, and iron, the raw materials of everything we now call home. When that oxygen drifted into cooler regions of space, it met with free hydrogen, 2 atoms for each one of itself, and water began to assemble in invisible vapor, molecule by molecule, in the thin interstellar clouds that drift between stars. Out there, in the chill between galaxies, water froze onto grains of cosmic dust, forming thin, icy shells that floated for eons. Some of those grains coalesced, gathering mass, growing into comets and asteroids, the wanderers of the early solar system. They carried frozen oceans locked inside them, traveling endlessly through the dark until gravity found them useful. The young Earth was still molten then, wrapped in haze, its surface too, hot for liquid to exist. But as the planet cooled and gravity steadied its spin, it began to call those icy travelers inward. When the first comets collided with Earth, they shattered in bursts of steam and light. Their frozen cargo vaporized, rising into the atmosphere, where it condensed and fell again as rain. For millions of years, this cycle repeated impact. Vapor, rain, until entire basins filled and the world turned blue. The seas we know today are built from the ruins of those ancient impacts, a memory of ice delivered across unimaginable distances. Every wave is a whisper from space, every droplet a relic of a much older universe. But water didn't only arrive from above. Deep inside the planet, hydrogen and oxygen found each other again in the chaos of molten rock. When volcanoes erupted, they exhaled vapor from the planet's lungs, adding to the sky's growing reservoir. Steam rose, condensed, and returned as storms, cooling the crust and thickening the atmosphere. It was an endless conversation between fire and air, stone and vapor, until the surface softened enough for oceans to settle into their basins. Earth became a mirror, reflecting the cosmos that had built it. Imagine that transformation. The world, once a landscape of flame, slowly smothered by clouds, then washed clean until continents were islands and the sky gleamed with blue. The same molecules that once drifted between stars were now forming rivers, tides, and storms. Lightning struck through those waters, stirring carbon chains and simple sugars, perhaps even the first flicker of life. In this way, water was both midwife and memory, carrying within it the conditions for creation and the echo of the stars that made it. Even now, traces of that ancient journey remain. The isotopes of hydrogen within seawater bear the signature of distant comets, and the ratio of heavy water to light reveals the fingerprints of stellar chemistry. To hold a handful of water is to touch the oldest substance on Earth, older than the rocks beneath your feet, older than the moon that shapes its tides. Each drop has wandered across epochs, evaporating, freezing, falling again, moving from ocean to cloud to cell in an endless cycle of rebirth. We often think of water as belonging to this planet, but that's not quite true. It's a visitor from deep time, a traveler that found a home here. It flows through us as it once flowed through space, unchanged in essence, though transformed in form. Every sip you take contains atoms that once drifted near the heart of a supernova, atoms that have passed through comets, glaciers, and storms. You carry within you the same cosmic material that forged the seas and shaped the sky. The next time rain falls against your window, consider that each droplet began its story long before there was a planet to receive it. It wandered through the vacuum, frozen and patient, until gravity and time conspired to make a world soft enough to hold it. That rain is a return, a homecoming. It is the oldest traveler in the universe finding its way back, over and over, through the endless turning of the earth. In every pool and river and storm, the universe remembers itself. Water is the link between what was and what is, the thread that binds our small world to the fires that once lit the first stars. And though it seems ordinary, flowing from taps, filling clouds, running beneath our skin, it carries the memory of creation, a quiet proof that even the most familiar things are made of wonder. If you could shrink yourself small enough to drift inside a single living cell, you'd find yourself surrounded not by empty space, but by water, an entire world of it. Every corner, every thread, every pulse of motion is soaked in it. Water is not a backdrop to life. It is the stage, the script, and the unseen hand that holds the performance together. Within its quiet chemistry lies the secret that makes existence possible, the delicate balance that lets molecules meet, react, and become something more. Each water molecule is like a tiny magnet, one end gently positive, the other slightly negative. This uneven charge, known as polarity, turns simple H2O into an architect of connection. Positive sides reach for negatives, negative sides reach for positives, and in this constant dance, the molecules link together through fragile hydrogen bonds, so fleeting they break and reform trillions of times each second, yet strong enough in numbers to give water its unique cohesion. That's why it beads on a leaf, climbs through roots, and holds itself together even as gravity tries to pull it apart. The whole surface of the world is shaped by these invisible threads, stretching and releasing, binding droplets into rivers and tears. Inside the cell, this same polarity becomes something far more intricate. Proteins fold because of it. DNA spirals because of it. Membranes hold their shape because of it. Each strand of life's code depends on water's ability to attract and repel, to create tiny pockets of charge where complex molecules can settle into perfect formation. Remove water, and the instructions of life unravel. Amino acids refuse to assemble. Enzymes stiffen. The machinery of existence grinds to a halt. It isn't just that water supports life. It is that life itself is written in water's language. At the boundary of every cell, thin membranes made of fat-like molecules create barriers between inside and out. These membranes are miracles of selective permeability. They keep the chaos of the world at bay, while allowing what's needed to pass through. And it's water that teaches them how to do this. Because it loves charged molecules and avoids uncharged ones, it forces the membrane structure to self-organize hydrophilic heads facing outward toward water, hydrophobic tails turned inward away from it. Without water's preference, the barrier would collapse, and every cell would dissolve into its surroundings. In this way, water doesn't just fill the world of life, it defines its borders. Look closer still, and you'll see water as the messenger that carries everything a cell needs to live. Nutrients drift through it. Electrical signals glide across it. It acts as both highway and harbor, allowing reactions to happen at precisely the right speeds. In most substances, heat brings chaos, but water absorbs energy gently, buffering life from extremes. That's why your body can maintain its narrow temperature range, why oceans cradle ecosystems that flourish for millennia. Without that thermal patience, existence would be too fragile to survive its own energy. Even surface tension, the force that makes droplets hold their shape, becomes an engine of life. Insects skim across ponds because of it, their weight distributed on an elastic film of hydrogen bonds. Raindrops cling to leaves and fall at just the right rhythm to feed roots without washing them away. Deep in your lungs, the same principle allows the tiny sacs of air called alveoli to open and close without collapsing. Every breath you take powered by water's balance between cohesion and flexibility. Each heartbeat, each inhale, each cell division is written into the choreography of water's properties. If you trace back far enough, the first living molecules likely formed in the thin layers where water met rock and air. There, the tension of droplets concentrated the right ingredients, amino acids, sugars, and lipids, until they joined into self-replicating chains. The water didn't simply host these reactions, it arranged them. Its polarity sorted the charged from the neutral, aligned shapes, slowed some motions while quickening others. It was the quiet chemist, turning chaos into pattern. In a sense, life began the moment water learned how to listen, to respond to the charges around it, to form and break bonds in rhythm with the environment. What's astonishing is that this same pattern continues within us. Your blood, your saliva, the fluid around your brain, all are descendants of that original ocean, still conducting the same dance of attraction and release. Every thought you have depends on ions gliding through watery channels. Every memory you hold is stored in a network of molecules shaped and stabilized by the same hydrogen bonds that ripple through a raindrop. You are, in every measurable way, a walking tide pool, an echo of the first waters that ever cooled on a young earth. And yet, for all its familiarity, water remains beyond imitation. Scientists have tried for decades to find substitutes that could support life elsewhere: liquid methane on Titan, ammonia oceans in distant systems, but none match water's versatility. Its strange chemistry allows order to rise from randomness, structure from fluidity. It is the only liquid that can dissolve almost everything, the only one that becomes less dense as it freezes, the only one that holds its shape long enough for complexity to take hold. It may be that the laws of physics themselves are fine-tuned to make water work, and through it, to make life inevitable. When you lift a glass of it to your lips, you are holding the blueprint of existence. It's the same design that shapes coral reefs, clouds, and your own reflection. Every molecule has spent billions of years practicing balance between charge and neutrality, chaos and structure, freedom and connection. In that fragile equilibrium lies everything that breathes, grows, and dreams. Life is not simply surrounded by water. It is made from its memory, written in its bonds, and carried forward in its endless, flowing script. If the earth had a memory, it would live in the oceans. Every current, every layer, every grain of salt holds the imprint of what has come before. Long before continents found their shape, before forests grew or creatures walked on land, the seas were already remembering. They recorded the first rainfall that cooled the planet's molten skin, the breath of early volcanoes, the slow exhale of the newborn atmosphere. Even now, the oceans carry those ancient stories, not as words or symbols, but as temperatures, salinities, and silent rhythms that pulse through the deep. The oceans did not form all at once. They gathered over millions of years, drop by drop, from rain that fell out of endless gray clouds. The air then was thick and violent, laced with ash and lightning, but every storm cooled the surface a little more. Water pooled in basins, merged into seas, and finally spread into the vast, continuous blue that would come to define the planet. Once they arrived, they never truly left. The same water that filled those primal basins still moves among us today, evaporating, condensing, raining down, flowing back again. The ocean is not a place, it's a cycle, a breathing organ that spans the planet's skin, inhaling and exhaling with each turning of the wind and tide. Beneath its glittering surface, the ocean is a world of layers and hidden motion. Sunlight reaches only a shallow fraction of it, barely a few hundred feet, leaving the rest in a perpetual twilight that deepens to complete darkness. In those unseen depths, temperature and salinity act as invisible cartographers, mapping the movements of water through density and depth. Warm, less salty water floats near the surface, while cold, dense water sinks and slides along the seafloor. This constant circulation creates vast conveyor belts that connect the poles to the equator, carrying heat, carbon, and memory from one end of the planet to the other. These underwater currents move slowly, almost imperceptibly, yet their influence reaches everywhere. A parcel of deep water that sinks near Greenland may take 1,000 years to surface again in the Pacific. As it travels, it records the temperature, the chemistry, even the dissolved gases of its journey, like an ancient traveler keeping a journal in silence. When scientists collect samples from these depths, they're not just studying water, they're reading history. The ratio of oxygen isotopes can tell them how warm the planet was when that water last saw the light. The traces of carbon reveal the breath of forests and volcanoes long vanished. The ocean's salinity, too, is a storyteller. It carries the signature of evaporation and rain, of rivers pouring minerals from eroded mountains, of melting glaciers diluting the salt of the deep. Each region has its own fingerprint, a unique balance of salt and temperature that marks where it came from and where it's been. Even the smallest variations whisper of global shifts. A meltwater pulse here, a monsoon there, the slow swing of climate patterns that steer wind and storm. When the salinity changes, so does the rhythm of the currents, and the Earth's heartbeat adjusts in turn. In its own way, the ocean listens as much as it speaks. Sound travels faster and farther underwater than through air, turning the deep into an archive of echoes. Whales call across entire ocean basins, their voices carried by the slow vibration of molecules. The crash of waves against cliffs, the rumble of distant quakes, the sigh of icebergs breaking apart. All of it travels through the water, layering the sea with constant sound. Scientists use these vibrations to map the ocean floor, to measure the pulse of tides and storms. But nature has been doing it since the beginning. Every frequency that moves through the ocean stirs its memory a little more, another mark on an ancient and endless recording. Even temperature itself is a kind of script. The ocean absorbs heat like a vault, storing decades of sunlight and slowly releasing it through time. The upper layers warm and cool with the seasons, but the deeper layers shift only over centuries. This slow turnover means the water that touches your toes at the shore today might contain the faint warmth of sunlight that fell before recorded history. The ocean is the planet's memory, not because it remembers quickly, but because it forgets so slowly. Sometimes it reveals its memories in sudden bursts, when deep water wells up along coastlines, bringing with it nutrients from the dark, feeding blooms of life that color the sea for miles. Those surges are the ocean remembering fertility, the deep feeding the shallow, the past nourishing the present. And in other moments, the ocean remembers loss. It reflects the melting of glaciers, the acid of too much carbon, the rising heat that spreads through its currents. It keeps every secret, even the ones we wish it didn't. If you could listen closely enough, you might hear it, the soft murmur of a planet recounting its history through movement and sound. The hiss of a breaking wave is the echo of a 1,000-mile journey. The stillness of a calm bay is the pause between centuries of change. The ocean doesn't speak in our language, but its patterns are a kind of poetry, written in tides and temperatures, in swells that stretch across hemispheres. We often think of memory as something fragile, a fleeting image in the mind. But the ocean shows us another kind, a memory that endures through weight and depth, through pressure and silence. Every drop of seawater has been somewhere else, touched another shore, mingled with rain, drifted under ice, and returned again. It remembers the birth of the planet and the lives that rose from its depths. To stand at the edge of the sea is to face that memory in motion, to look into a mirror that holds not just the present moment, but the story of everything that came before. Above us, an invisible ocean drifts and churns, vast as the one that covers the planet below. You cannot see it, yet it moves over every mountain, every field, every sleeping city, a silent current made not of liquid, but of vapor, endlessly traveling from sea to sky and back. Again, this hidden ocean weighs more than you might imagine. At any moment, the atmosphere holds nearly as much water as all the rivers on Earth combined, suspended in the air as an unseen tide. It moves quietly, shaping weather, carrying heat, and deciding where life will flourish or fade. It begins with sunlight. When the morning rays strike the ocean's surface, they give energy to molecules that dance faster and faster until some escape entirely. Each one lifts off into the air, joining countless others rising as invisible steam. This is evaporation, the ocean, breathing upward. From lakes, rivers, soil, and leaves, vapor rises into the atmosphere, carrying traces of the world it left behind. The scent of salt, pollen from trees, minerals lifted from rock. These drifting molecules wander freely for days, carried by wind, caught in currents that circle the globe. They are the sky's migration droplets waiting to be born. As the vapor climbs, it cools. The air can only hold so much water, and when it reaches its limit, condensation begins. Tiny particles, dust, pollen, even microscopic salt become the anchors around which droplets form. Each particle gathers moisture until a minuscule sphere of water takes shape, too small to fall, too light to see. Billions of these droplets together form a cloud, a floating sea that glows white because sunlight scatters through it. What looks like stillness from below is anything but. Inside a cloud, the air is alive with motion rising, sinking, swirling, colliding. Droplets merge and break apart in a ceaseless rhythm, growing heavier until gravity begins to notice them. When droplets reach just the right size, they start their descent. They fall through layers of air that twist and cool, sometimes freezing into crystals, sometimes collecting others as they tumble, each one changing shape on the journey down. What we call rain is simply the moment the sky remembers gravity. A raindrop is a reunion, a piece of the sea returning home. And though it feels instant when it touches your skin, its creation may have taken weeks of travel across oceans and continents. Some droplets fall back into the sea, completing the cycle. Others sink into soil, becoming groundwater or feeding streams that flow once more to the ocean. Every rainfall is the continuation of a journey billions of years old. Within this cycle lies an astonishing order. The water that evaporates from the equator's warmth may fall months later as snow in the polar regions. Moisture rising from tropical forests drifts outward, feeding storms that reign over deserts far away. The atmosphere is laced with what scientists call atmospheric rivers, long, narrow bands of moisture that stretch thousands of miles, carrying more water than the Amazon River itself. They move invisibly, tracing paths dictated by temperature and pressure, bending around mountains and circling the planet in slow motion. When one of these airborne rivers reaches land, it releases its weight in days of rain, sometimes nurturing fields, sometimes flooding valleys. The sky is not empty. It is full, breathing and flowing like a sea turned inside out. Clouds themselves are the most expressive part of this hidden ocean. They build towers taller than mountains and stretch sheets of silver across the horizon. Some shimmer thin as silk, while others gather like fortresses of gray. Each one is a balance between rising warmth and falling cold, between the desire of vapor to ascend and the pull of earth to bring it back down. Even the smallest wisp carries the memory of temperature and wind, holding the story of the air around it. Watch them long enough, and you can almost read the weather's language, its slow inhale before a storm, its long exhale when the world is at peace. The sky's ocean is also an architect of light. When vapor condenses into droplets just the right size, sunlight bends through them to form rainbows. Ice. Crystals high in cirrus clouds create halos, arcs of color that circle the sun or moon. These optical songs are reminders that water doesn't only shape the world through weight and flow, it also paints it. A storm may darken the land, but when it breaks, the sky glows with a clarity born from water's prism. Even the gentlest breeze carries this cycle forward. Every breath you take contains molecules that have drifted through clouds, fallen as rain, and risen again as mist. The same vapor that once passed over the Pacific might now hover above a forest, waiting to fall into the soil that feeds a river leading back to that same ocean. It is a choreography of renewal, guided by temperature, sunlight, and gravity. In the time it takes for a cloud to form and dissolve, an entire world is refreshed. Yet, for all its movement, this hidden ocean also carries stillness. High above storms and cities, the air holds water so fine it will never fall, suspended indefinitely in thin, frigid layers that circle the globe. There, above the reach of weather, vapor becomes part of the sky itself, a veil of moisture that softens the planet's light and keeps warmth from escaping into space. It is the atmosphere's quiet reservoir, unseen but essential, the soft breath that makes Earth habitable. When you look up and see the slow drift of clouds, remember that they are not merely shapes in the sky, but living fragments of a much greater sea. Each one is a moment in the planet's long memory, a pulse in its endless exchange between water and air. The rain that falls today has fallen before, countless times, in countless forms, on deserts, jungles, mountains, and faces. The sky's hidden ocean is the oldest traveler of them all, circling endlessly above us, always moving, always returning home. Ice is one of water's strangest disguises. Most substances grow heavier as they cool, their molecules pressing tighter together, but water refuses this rule. As it freezes, it spreads apart, expanding into a fragile lattice that takes up more space than the liquid it once was. This defiance gives ice a rare gift. It floats. That simple act, so small it goes unnoticed in a glass of water, has saved life on this planet countless times. Without it, the world would be unrecognizable. The oceans would freeze from the bottom up, rivers would turn to solid stone, and the cradle of life itself would vanish beneath sheets of cold that never melt. The secret lies in geometry, in the delicate dance between hydrogen and oxygen. Each water molecule is shaped like a tiny letter V. Its two arms, the hydrogens, tilted at an angle from the oxygen's center. When the temperature drops, these molecules slow down and begin to arrange themselves in a pattern held together by hydrogen bonds. Instead of pressing close, they lock into a hexagonal framework, each molecule keeping its neighbors at a respectful distance. It's a structure full of empty space, beautiful in symmetry, but sparse, like a crystalline web. That openness is what makes ice less dense than liquid water. It is, quite literally, a solid made of emptiness. Because of this, ice becomes a barrier between the living and the lifeless cold above. When lakes freeze in winter, the ice forms on the surface first, sealing the liquid water below like a protective lid. Beneath that lid, life continues, a secret kingdom of fish and plants and microorganisms surviving in slow motion. The ice traps heat within, while snow above it acts as insulation, reflecting away the worst of the chill. Even in the heart of January, beneath a frozen pond, the water rarely drops below a few degrees above freezing. The animals drift quietly through the dim light, waiting for the season to shift. They owe their survival to a quirk of physics that no other common liquid shares. The floating ice does more than protect its sculpts. Glaciers, those moving mountains of compressed snow, carve valleys and shape continents. As they slide and melt, they grind rock into fertile soil, filling rivers and lakes that sustain future life. Even the polar caps, vast and gleaming, regulate the planet's temperature by reflecting sunlight back into space. The whiteness of ice keeps the world from overheating, a mirror cast across the poles that balances Earth's energy. If that mirror darkens or melts too quickly, the planet warms in response, a delicate feedback written in geometry and sunlight. There is a quiet poetry in how ice forms. At first, it begins invisibly, a few molecules locking together, then more joining them, growing in jagged patterns that spread outward like veins of light. Snowflakes are simply this process made visible, each one a fleeting expression of molecular order, shaped by air currents and humidity as it drifts through the clouds. No two are identical because no two paths through the sky are the same. When snow settles on the ground, it carries the blueprint of the atmosphere it fell from, a frozen archive of temperature and air. In polar regions, these layers build year after year, stacking stories of past climates that scientists now read in ice cores like pages of a glacial book. Ice also remembers sound differently than water. A crack on a frozen lake can echo for miles, a haunting, elastic note that bends through the air like the groan of the planet itself. That sound is energy traveling through crystal, through bonds that have tightened but not broken. In the deep Arctic night, even the smallest shifts create resonances that hum across the ice fields, reminders that this stillness is alive. Underneath, the water stirs, aware in its own way that it is being watched over by its frozen reflection. When spring comes, the first cracks appear like veins of light spreading across the surface. Sunlight seeps in, melting the edges, turning solid back to liquid, tension into flow. The cycle begins again, the cold releasing its hold, the water remembering motion. In this transformation, there is something almost spiritual, a return to flexibility, to change. The ice doesn't vanish. It becomes invisible again, dissolving back into the system that created it. Every droplet that melts carries within it the shape it once held, an imprint of the bonds that allowed it to float. It's easy to take ice for granted, to see it as still, lifeless, or temporary. But in truth, it is the planet's pause button, a necessary rhythm between warmth and cold, motion and rest. When it forms, life slows but does not end. When it melts, life begins again. Its buoyancy, born from a tiny molecular angle, keeps the world's waters breathing, cycling, and alive. And so, in every frozen pond and drifting flow, the same quiet miracle repeats itself. The world freezes, but it does not die. Ice rises instead of sinking, holding life close, guarding it through the dark, until light returns. In that paradox, weight turned to buoyancy, stillness turned to protection. Water shows its final secret. Even in its coldest form, it is still a giver, still a vessel for life. Every river begins as a thread, a trickle of meltwater from a glacier, a spring bursting from underground stone, a storm spilling across a hillside, small, uncertain movements that gather into flow. From those beginnings, rivers learn to carve, to carry, to shape. They are the restless sculptors of the earth, cutting through mountains, spreading fertile soil, and connecting distant worlds through motion alone. What begins as a whisper in the highlands becomes a voice that rearranges continents. A river's journey is an act of patience. It begins with erosion, the quiet persistence of water, wearing down rock, grain by grain. Each drop presses into tiny fractures, freezing and thawing, expanding and prying apart. Over time, those fractures widen into gullies, gullies into valleys, valleys into vast canyons. It seems impossible that something so soft could carve stone, but time amplifies gentleness into power. The Colorado River spent millions of years slicing through layers of ancient sandstone to create the Grand Canyon, its waters patiently lowering the ground as continents shifted and climates changed. In every meandering bend and jagged cliff, you can see the signature of water's steady hand. Yet, rivers are not just destroyers, they are also builders. As they carve the land, they carry its fragments away, sand, silt, and minerals that will one day become the foundation of new life. When the current slows at bends, in floodplains, or near the sea, these materials settle, layer upon layer, forming deltas and plains rich with nutrients. Some of the most fertile lands on Earth, like the Nile Delta or the valleys of the Indus and Ganges, were created this way. Civilizations have risen along these edges of water and earth, depending on the pulse of seasonal floods that renew the soil. Every grain of fertile ground was once part of a mountain far upstream. Rivers, in their ceaseless motion, are the planet's way of recycling the old into the living. As they travel, rivers gather not just sediment, but memory. They record rainfall and drought, carrying the chemical traces of the places they've touched. A drop of water that falls in a forest may carry the faint acidity of decomposing leaves. Another from a glacier might hold the mineral fingerprint of ancient ice. Together, they flow toward the sea, mingling the signatures of entire ecosystems. Scientists can read these traces like a diary of the landscape, following the path of erosion, pollution, and time itself written in the chemistry of the current. Rivers also carry sound, not the simple noise of rushing water, but an ever-changing harmony, pebbles clicking, branches tumbling, the rhythmic surge against bends and banks. If you listen long enough, you begin to hear the shape of the land in the river's voice. A narrow gorge hums with pressure, a wide floodplain murmurs in slower tones. Even the fish within the current sense these vibrations, following the invisible language of flow. For them, the sound is a map, the guide that tells them when to spawn, where to hide, how to move with the pulse of the world. Across deserts, rivers become miracles. They thread through sand like veins of silver, bringing life where none should exist. The Nile, the Niger, the Tigris, all carve their way through arid lands, their margins blossoming into green corridors. Along their banks, animals gather, plants root, and people settle. Entire cultures depend on the rhythm of water rising and receding, on the promise that the flood will come again. When the river dries, its absence is not just a lack of water, it is the pause of life itself. Even when rivers disappear underground, their work continues. In limestone country, they carve caverns filled with stalactites and echoing chambers. In karst plains, they vanish into sinkholes, re-emerging miles away with the same quiet persistence. Underground rivers are the secret architects of landscapes we rarely see, shaping the world from within, their touch felt in springs and wells that emerge unexpectedly from the earth. Eventually, every river meets its end. At the edge of the land, its current slows, spreads, and finally merges with the sea. But even here, it continues to shape. Deltas grow outward, carrying soil far beyond the shore, extending continents into the ocean. In these mingling zones of salt and fresh water, life flourishes in abundance. Mangroves, marshes, fish, nurseries, and flocks of migrating birds that rely on the nutrients the river has gathered along its journey. What looks like an ending is only a transformation, the moment when the river gives itself back to the whole. In the grand cycle of water, no river ever truly dies. The same molecules that tumble through rapids today may rise tomorrow as vapor, drift across the sky, and fall again as rain hundreds of miles away. They will find another slope, another path, another song to sing through the valleys. Each river is just one verse in an unending hymn, reshaping the world note by note, season by season. If you stand beside a river and watch it move, you can feel the history it carries. Mountains worn to dust, glaciers long vanished, forests that once lined its banks. It is a story written in motion, a reminder that even the gentlest force can transform everything it touches. Rivers don't rush to their destination. They teach the earth, and us, the art of persistence, how to flow around obstacles, how to carve meaning through time, how to create by letting go. And as long as they move, the planet continues to breathe, its continents slowly molded by the patience of water. Imagine a single drop of water resting on the surface of a quiet lake. The air above it is still, the sunlight warm, the world seemingly unmoving. But inside that droplet, every molecule is vibrating, shifting, waiting. Among them is one tiny traveler, a single H2O molecule about to begin a journey that has no end. Its path will cross sky and soil, ocean and ice, body and breath, looping through time in ways that no living thing can follow. Yet it moves without hesitation, obeying only the invisible pull of energy and gravity, forever caught in the rhythm of the planet's breath. When the sun's rays strike the lake, they pour energy into its surface, and our molecule begins to dance faster. Bonds stretch and loosen until, in one flickering instant, it breaks free from the liquid below. It lifts into the air as vapor, lighter than mist, invisible now but alive with motion. Around it, thousands of other molecules rise too, forming an unseen cloud of steam that drifts upward into cooler air. From the lake's stillness, our traveler has entered the sky's restless tide. This is evaporation, the first act of transformation, where heat, becomes flight. High above, the air grows thinner, colder. The vapor slows, and our molecule meets others, clinging together around tiny specks of dust and salt. One by one they join, forming a microscopic droplet suspended in the wind. That droplet joins millions more, each one reflecting sunlight until the sky itself becomes a floating ocean of white. From the ground we see this as a cloud, soft and weightless. But inside it, motion never stops. Air rises and falls, pushing droplets together until some grow heavy enough to fall again. Our molecule tumbles from its perch, caught in a raindrop beginning to descend through the miles of air it once climbed. The fall is long, yet brief. As it plunges, the droplet collides with others, merging and splitting, gaining speed. Wind buffets it, reshaping it into a teardrop form that dances in the air. For a moment, sunlight catches its curve, scattering colors, a tiny prism carrying the entire spectrum of the sky. Then it lands, splashing, onto a leaf, spreading across its veins before dripping to the earth below. The drop seeps into the soil, sinking through layers of sand and clay, finding the dark coolness beneath the surface. There, among the roots and stones, our molecule joins the hidden world of groundwater. Underground, water moves slowly, inching through the tiny spaces between grains of rock. The world here is silent but alive. Bacteria feed on minerals, roots draw sustenance, and ancient aquifers breathe in centuries. Our molecule drifts through this subterranean labyrinth, absorbed by the roots of a willow, drawn upward through the trunk into the leaves. It joins the sap that rises each morning, pulled by the same tension that holds water together in droplets and rivers alike. When the wind stirs the branches, the leaf opens its pores, and our molecule escapes again into the air as vapor. It has returned to the sky, lifted by the same heat that once freed it from the lake. But the journey doesn't always repeat the same way. Sometimes our traveler freezes into ice crystals high in the clouds, joining others to form snow that drifts gently down. Buried in a mountainside, it waits for years before melting into a stream. Sometimes it falls on the ocean, joining waves that crash against distant shores. It might pass through the gills of a fish, the stem of a flower, or the lungs of a child taking a breath on a rainy morning. Each time it changes form, it learns a new language: liquid, vapor, solid, living, unseen. The water cycle is not a loop, but a story told in infinite variations. A molecule can spend days in the atmosphere or centuries locked in polar ice. It can flow as a river, rise as mist, or hide deep within a mountain aquifer. Yet no matter where it goes, it remains part of the same endless circulation, the planet's silent metabolism. In this way, every drop of rain that falls today has existed before, countless times, in countless places. The water in your veins may once have fallen on the skin of a dinosaur, flowed beneath a glacier, or drifted as vapor above an ancient sea. Sometimes, at dawn, when fog curls low across the ground, you can almost see the cycle happening all at once. The earth exhaling moisture into the air, the sky condensing it back into dew. It's as if the world is breathing, inhaling and exhaling through water alone. Our single molecule might be there in that fog, suspended for a heartbeat between sky and soil, between ascent and return. Eventually, it will fall again, and the journey will continue. There is no final destination, no rest, only transformation. The molecule will move through rivers and clouds, through living bodies and open air, never aging, never ending. It will watch continents drift, climates change, and species rise and vanish, all while remaining itself unchanged, eternal, the same delicate geometry that has existed since the universe began. Water's journey is the story of persistence. It is the movement of memory across time, the quiet thread that ties everything living and unliving together. The molecule that rose from the lake will rise again and again, carried endlessly through the heart of the world, reminding us that nothing truly ends it, only flows. At first glance, water seems to obey gravity without complaint. It flows downhill, gathers in valleys, settles into the lowest place it can find. Yet hidden within its calm obedience is a quiet defiance, a set of invisible forces that let it climb, cling, and stretch in ways that seem to contradict the laws that bind everything else. These unseen powers are what allow giant trees to drink from their roots, flowers to bloom, and life itself to circulate. Every droplet that forms, every leaf that glistens, every tear that falls does so because of these forces working in silence, holding the world together molecule by molecule. Water's most intimate magic begins with cohesion. Each molecule carries a subtle charge, one side slightly positive, the other slightly negative, and these opposite ends are drawn to each other, like countless tiny magnets. When two water molecules meet, they form a fleeting bond, break apart, and meet again. Alone, these connections are fragile, lasting only a heartbeat. Together, they create an invisible network strong enough to hold oceans in shape and let droplets bead on the tip of a blade of grass. Cohesion gives water its unity. It's what allows a stream to curve and pull itself along, each molecule tethered to the next in an endless chain of motion. Then there is adhesion, the sister force that lets water attach itself to the world around it. Where cohesion pulls molecules together, adhesion draws them outward, letting them cling to surfaces, rock, glass, skin, leaf. When rain hits a window, it doesn't simply slide away. It pauses, spreads thin, grips the surface as if reluctant to leave. Inside plants, this same tendency allows water to latch onto the walls of microscopic tubes and begin its ascent from the soil toward the sun. Without adhesion, rivers would move like mercury, rolling away from everything they touched. With it, they shape the land, soaking into soil, gathering nutrients, and feeding life. Surface tension is where these two forces meet. It is the invisible skin stretched across the surface of every puddle and pond, the boundary where cohesion and adhesion find balance. On a molecular level, the water at the surface has no neighboring molecules above it, so it binds more tightly to those beside and below. The result is a kind of elastic sheet strong enough for insects to walk upon, delicate enough to break with the fall of a single raindrop. Every ripple, every bead of dew, every trembling reflection exists because of this tension, the quiet equilibrium between holding on and letting go. In the towering redwoods of California, these same forces perform their most astonishing work. Imagine a tree as tall as a skyscraper, its roots buried deep in the earth, its leaves brushing the clouds. No pump, no engine. No heartbeat drives water from root to crown, only the interplay of cohesion and capillary action. Inside the tree's xylem, narrow tubes thinner than a strand of hair draw water upward. Each molecule clings to the next and to the walls of the vessels themselves. As sunlight warms the leaves, water evaporates from their surface, pulling the next molecule upward in an unbroken chain that stretches more than 100 meters high. The entire column moves as one, drawn upward, not by force, but by connection. When you stand beneath a redwood and feel the cool dampness in the air, you are standing inside the breath of this process, a cathedral of physics that never stops moving. This same phenomenon happens on a smaller scale within us. Every cell in the human body depends on capillary action to carry water through microscopic channels, feeding tissues, cooling organs, washing away waste. Blood itself, though filled with cells and proteins, is a liquid symphony orchestrated by water's properties. Each heartbeat sends it through veins and arteries lined with the same wet adhesion that guides sap through trees. The cohesion between molecules allows the fluid to move smoothly, while the tension between surfaces keeps it in motion, never separating, never still. Water doesn't just fill us, it flows through us with purpose, obeying laws that feel almost emotional in their design. Even at rest, these forces shape the smallest details of the world. A drop of water resting on a leaf curves into a sphere because the surface molecules pull inward, seeking balance. That same pull allows droplets to merge, forming rivulets that trace the veins of the leaf before dripping to the ground. When the sun rises, surface tension breaks under heat, and the droplet becomes vapor again, lifted away into air. Every stage of that transformation, clinging, merging, releasing, is an echo of the same delicate physics that holds the planet's cycles in motion. It is easy to forget that these invisible interactions form the foundation of life. Without surface tension, raindrops wouldn't form, rivers would lose their shape, and clouds could not gather. Without capillary action, no tree could rise, no flower could bloom, no breath could move through lungs. These are the unseen strings of the natural world, tugging, balancing, binding everything together. Water never fights gravity outright. It finds other ways to rise. It climbs through connection, one molecule pulling another, step by step, until the entire world drinks. It holds itself together not through strength, but through trust, through bonds that are always breaking and reforming, fragile but unending. In that delicate persistence lies the secret of every living thing. That unity, however fleeting, can lift even the heaviest weight. Salt is the sea's quiet secret. It hides in every wave, every misted breath of the ocean, every droplet that dries white on your skin after a swim. It is what gives the water its weight, its taste, its strength. Without it, the seas would be as fragile as rain, their rhythms unsteady, their balance undone. The salt within them is ancient, born from stone, carried by rivers, concentrated by the slow patience of time. It is the reason the ocean never spoils, why it preserves life even as it seems to devour it. The sea's salt is both memory and equilibrium, the mineral pulse that holds the planet steady. Long before there were continents shaped as we know them, the first rains fell on a raw volcanic earth. Those rains struck new rock, dissolving minerals and washing them down into basins that would one day become oceans. Sodium, chloride, magnesium, calcium, all the restless elements loosened by water's persistence were carried away grain by grain. Over eons, rivers acted as veins, delivering the planet's minerals to the sea faster than they could be buried or reclaimed. As the water evaporated beneath the young sun, the salts remained behind, layer upon layer, until the ocean reached the salinity it holds today. Every wave that touches shore carries the chemical echo of that primordial erosion. Salt may seem simple, but it defines everything about the ocean's character. It thickens the water just enough to let ships float higher, to keep swimmers buoyant, to allow currents to flow with purpose and weight. The balance between salt and temperature governs the great conveyor belts of circulation that carry warmth from the equator to the poles. A fraction of a percent, more or less, and the whole rhythm of the planet's climate would falter. Salinity decides where ice can form, how deep water will sink, and how much carbon the sea can absorb. It shapes the heartbeat of hurricanes, the migration of plankton, the shimmer of coral reefs. The world's weather and its breath depend, quietly and completely, on salt. But within this chemistry, life found its equilibrium. Every cell in every living creature carries a trace of the ocean inside it, a reflection of its salinity. Our blood, our tears, even the fluid that cushions our eyes and brain all mimic the sea's ancient proportions. It's as if life, upon leaving the water, took a small piece of it along, a memory encoded in the chemistry of survival. Too much salt, and cells shrivel. Too little, and they burst. In this delicate range between extremes, existence flourishes. Fish have learned to drink seawater and filter out the excess. Mangrove trees exhale salt through crystals on their leaves. Seabirds weep it through special glands hidden near their eyes. Every living thing that touches the ocean has found its own way to live with salt's paradox, to depend on what could so easily destroy it. The ocean's saltiness is not uniform. Near the mouths of rivers, it softens, diluted by freshwater plumes that ripple outward into the waves. In the still centers of deserts where heat steals moisture, it grows concentrated, thick, and sharp. These differences drive the sea's motion, setting currents into motion as lighter, fresher water slides over heavier, saltier depths. The ocean stirs itself endlessly, seeking balance it will never quite reach. Even in the calmest blue expanse, that hidden struggle continues, a slow and silent choreography between salt and sun, density and depth. For sailors of old, salt was both a friend and a warning. It preserved food for journeys beyond sight of land, but it also coated everything it touched with its stubborn crystals, corroding wood and metal alike. For them, the sea's salt was proof of its power, something eternal and unyielding. They tasted it in the wind, felt it drying on their lips, watched it form a pale crust on ropes and sails. It marked them as belonging to the ocean, claimed them in quiet ways they couldn't wash away. Even now, when the tide recedes, it leaves its ghost behind on rocks and piers, a glittering residue that whispers of the deep. On a planetary scale, salt is also the ocean's memory keeper. Its concentration has stayed almost constant for hundreds of millions of years. Even as mountains have risen and fallen, climates have warmed and cooled. This stability comes from the slow balance between rivers carrying minerals in and hydrothermal vents at the seafloor, pulling them back out. The ocean is always exchanging, never still, a vast equilibrium that holds steady through motion. It remembers the world's changes, but it does not forget itself. And yet, for all its chemistry, salt remains something deeply human. It seasons our food, heals our wounds, preserves our harvests. It connects our bodies to the sea we came from, reminding us with every grain that we are creatures of water. To taste salt is to taste origin. It's the flavor of rain turned to ocean, of time dissolved and made eternal. So when you stand by the shore and lick the salt from your lips, you are tasting the planet's oldest story. You are tasting mountains worn down to dust, rivers that have carried that dust across millennia. The unbroken lineage between storm and calm. The sea's salt is more than a mineral. It is the signature of time itself, crystallized in water. It is what keeps the ocean from ever truly ending, what allows it to cradle life and mirror the sky, what ties our own blood to the memory of the deep. In the outer reaches of our solar system, where sunlight fades to a pale whisper and the warmth of the sun can no longer reach, there are worlds made almost entirely of ice. They drift in darkness, orbiting distant planets like tiny frozen lanterns, their surfaces hard and bright as glass. Yet beneath that glacial armor, something extraordinary may be stirring. These moons, Europa around Jupiter, Enceladus around Saturn, and others farther still, hold oceans so vast that they contain more water than all of Earth's seas combined. And though they seem silent and still, the evidence suggests that those oceans may not be empty. Europa is perhaps the most haunting of them all. Seen through a telescope, it glows with a smooth, pale sheen, its surface etched with long crimson cracks that crisscross the globe like veins beneath translucent skin. Those scars are not marks of age, but signs of motion. Tides pulled by Jupiter's immense gravity flex and twist the moon's crust until it fractures, letting heat rise from within. The ice moves, groans, and heals again, as though the moon itself were breathing. Beneath that shifting shell, perhaps 20 kilometers thick, lies an ocean kept liquid by the friction of tides and the warmth of Europa's core. There, in the dark, beneath pressure and ice, conditions exist that look strikingly familiar to those that gave birth to life on Earth. Scientists have long dreamed of piercing that icy skin. They imagine probes melting downward, layer by layer, until they reach the hidden sea. What would they find? Perhaps nothing but salt water and silence, or perhaps something astonishing, simple microbes drifting in the black, feeding on minerals and heat rising from the rocky floor below. On Earth, life thrives in places once thought impossible, inside volcanic vents, within Arctic glaciers, under miles of stone. So why not there, in Europa's secret ocean, where sunlight never shines but warmth still lingers? If life exists there, it has never seen a sky, never known a surface, but it may have endured for billions of years, unseen and unimagined. Farther out, Saturn's moon Enceladus tells a similar story, but in its own wilder way. Though only a few hundred kilometers wide, Enceladus erupts with fountains that burst from cracks near its south pole, jets of water vapor and ice grains shooting hundreds of kilometers into space. When the Cassini spacecraft flew through those plumes, it tasted traces of salt, ammonia, and complex organic molecules, the chemistry of potential life. These geysers are windows into the ocean below, proof that liquid water touches rock in the depths of that tiny moon. That contact between sea and stone, driven by heat and pressure, is the same crucible that once birthed life here on Earth. Each plume is like a breath from a world we have never seen, but that shares our most basic ingredient, the longing to move, to flow, to change. The idea of oceans beneath ice once seemed impossible, but the more we look, the more we find. Ganymede, another of Jupiter's moons, may harbor several layers of liquid water stacked between frozen shells, each one squeezed by gravity and warmed by the planet's magnetic field. Even Pluto, cold and distant, shows hints of an ancient or lingering sea beneath its heart-shaped plain. Water, it seems, refuses to vanish, even in the most desolate corners of the solar system. It finds ways to persist, protected beneath ice, warmed by friction, waiting for discovery. If we could stand on one of these worlds, the view would defy every earthly instinct. Above would hang a sky the color of ink, filled not with stars, but with the looming bulk of a parent planet, striped, ringed, glowing softly in reflected light. Beneath our feet, the ice would creak with slow tides, whispering the sound of oceans miles below. The air, if there were any, would freeze breath in an instant. And yet, beneath that silence, something alive might drift in the darkness, unaware of how extraordinary it is to us, but ancient in its own quiet way. What makes these ice worlds so compelling is not only their mystery but their familiarity. They remind us that life doesn't belong solely to warmth and light. It can flourish in cold, in pressure, in shadow. On Earth, the deep ocean floor teems with creatures that feed on chemical energy instead of sunlight. There, entire ecosystems live on heat and minerals alone, proof that biology can write its story in places where the sun cannot reach. The same pattern may unfold far from here, in alien oceans under alien skies. To explore these places is to confront both wonder and humility. We send machines across billions of miles to gather whispers from plumes and reflections from ice, trying to decode a world that cannot yet be touched. Every image of Europa's cracked shell, every spectrum of Enceladus's plumes, every trace of hydrogen or carbon discovered in their spray, is a message from a world that may be alive. These signals remind us that Earth is not the only ocean world, that the same forces that shaped our seas are scattered across the cosmos, repeating themselves in silence. Someday, a probe may finally dive through Europa's crust, or sail through Enceladus's geysers again, tasting for signs of motion, metabolism, or memory. And if it finds even the simplest form of life, the smallest pulse of chemistry that defies stillness, it will change everything we know, because it would mean that water, the most ordinary miracle of all, does what it has always done. It finds a way to live, even in the coldest light of space. Sound moves differently in water. It doesn't drift softly like it does through air, fading with distance. It rushes, it presses, it clings. Beneath the surface, sound becomes touch, Vibration turned to movement, energy made almost solid. The ocean is dense, its molecules packed tightly together, and when one moves, the next follows almost instantly. A single sound wave can travel thousands of miles before fading, slipping through the water's endless corridors of pressure and depth. Down there, in that liquid silence, noise does not vanish. It lingers, transforms, and becomes a way for the sea itself to speak. On land, sound is fleeting. It carries stories through wind and air, but the moment it meets resistance, it breaks apart. In water, it finds endurance. Because molecules are closer together, the energy of vibration transfers faster, more than 4 times faster than through air. A sharp crack underwater becomes something almost physical, a pulse that you can feel in your bones before you truly hear it. To a diver suspended in the blue, every sound seems to come from everywhere at once. There is no clear direction, no horizon for the ear. The ocean surrounds you in all directions, pressing in with whispers that feel both near and infinite. Whales have long understood this language of vibration. They are the composers of the deep, crafting songs that ripple across entire ocean basins. A blue whale's call, low and mournful, can travel thousands of kilometers long enough for another whale half an ocean away to hear and answer. To them, distance is an illusion. They live in a world stitched together by sound. Each note tells a story of migration and memory, of mating and belonging. The songs change with the seasons, evolving like dialects, shaped by geography and time. A whale born in the Pacific will grow up surrounded by melodies completely different from those sung in the Atlantic, each population carrying its own cultural rhythm passed down through generations. In the deepest waters, where sunlight fades to black and sight is useless, sound becomes the only sense that matters. The snapping of shrimp forms a constant crackling chorus near coral reefs, so loud that submariners once mistook it for static. Fish drum against their own swim bladders to call for mates. Dolphins whistle and click in rapid bursts, their sounds bouncing back to them in echoes that form living images of their surroundings. Each pulse and reflection is a kind of sonar painting, a way of seeing with sound. For them, the ocean is filled not with darkness but with information, each echo revealing shape, motion, and presence. Humans first learned the power of underwater sound by accident. Submarines during wartime discovered that a single metallic tap could be heard for miles. Later, scientists realized that the ocean acts like a lens, bending sound waves through layers of temperature and pressure into what's known as the SOFAR channel, a deep band where sound can travel halfway around the world without fading. In this hidden corridor, a whale's voice or a rumble from an earthquake can circle the planet, carrying messages that no one ever intended to send. It is as if the earth itself keeps a low, continuous hum beneath the noise of wind and waves. But sound underwater is not just communication, it's emotion. A humpback's song can be mournful and vast, a series of haunting moans and ascending phrases that feel almost human in their longing. When hydrophones first captured these songs in the 1,960 seconds, people wept listening to them. The recordings were eerie and beautiful, filled with rhythm and repetition that sounded like music. In truth, it was music composed by creatures who breathe air but live in a medium made of resonance. Their songs are shaped by water's density, its clarity, its slow and patient way of carrying tone. Even a simple ripple, the brush of a fin, the fall of rain, each becomes percussion in the sea's endless composition. If you could hear beneath the surface, the world would sound alive in ways you've never imagined. The faint hiss of sand shifting on the seafloor, the creak of coral expanding with heat, the soft murmur of bubbles rising from volcanic vents. Together they form an oceanic symphony, a constant blend of low rumbles and high chimes. To the creatures who live within it, silence does not exist. Even in the calmest depths, the water hums faintly with the friction of molecules. The ocean is never truly quiet, yet water also softens what it carries. A note struck underwater stretches, blurs, loses its edge. High pitches fade quickly, low ones drift for ages. Music played beneath the surface becomes something ghostly and slow, as though time itself thickens. It's why the calls of whales sound, ancient even when they are new, and why the ocean seems to hold an echo of everything that has ever made a sound within it. The sea is not just a conductor of vibration, it's a memory. When you stand at the shore and listen to waves, you are hearing the same physics at work, scaled down to a human register. Each crash, each retreating hiss of foam is a fragment of that vast underwater conversation reaching the air. It is the ocean's language translated into one we can hear, the boundary where density meets air and becomes song. Sound may move faster below the surface, but here, on the edge of land, it slows just enough for us to understand that we are part of it too. Beneath the calm or fury of the waves, the ocean is always speaking. It tells its stories not in light, but in vibration. Each pulse, each resonance, each echo, another heartbeat of the planet itself. And though most of it passes unheard, it continues, endlessly, a music that outlasts every storm, every ship, every age. The sound of water is the sound of time, moving through us all. Light enters water and forgets itself. What was once straight becomes curved. What was once white splits into colors. What was once still begins to shimmer. Every beam that touches a droplet is bent, scattered, and reborn. In that bending lies the ocean's blueness, the rain's colors, the halos that encircle the sun and moon. Water does not merely reflect light, it transforms it, reshaping the way the world appears to our eyes. Through it, we glimpse the hidden geometry of color and motion, the delicate conversation between photons and waves that has been happening since the first dawn. When sunlight meets the surface of the sea, part of it bounces back toward the sky, while the rest dives downward, slowed and bent by the density of water. This bending refraction is what makes a stick look broken when half of it is submerged, what makes fish seem closer than they are, what gives the world beneath. The waves, its surreal fluidity. The light that enters the water does not travel straight. It curves and scatters, breaking into colors that fade at different depths. Reds and oranges vanish first, absorbed within the upper few meters. Yellow and green linger longer, fading into a turquoise glow. Blue remains, scattered and reflected from all directions until it fills the ocean with its calm, endless hue. That is why the sea appears blue, not because it mirrors the sky, though it often does, but because water itself absorbs the warmer tones of light and returns only the cool end of the spectrum. The ocean's color is not reflection but subtraction, a reminder that beauty often comes from what is taken away. In shallow lagoons, where sand reflects light upward, the water turns pale green. In deeper trenches, where sunlight cannot reach, it becomes black, a mirror of space itself. Between those extremes lies every shade of blue the eye can name, a gradient shaped by physics and depth, by the slow filtering of light through miles of water. When light strikes the surface at an angle, reflection and refraction compete. Some photons bounce away, others dive in, and the border between them becomes the shimmer we call a glint. Every sparkle on a wave is a moment of choice, a single ray deciding between two worlds. On calm days, the surface becomes a perfect mirror, turning the sky upside down. But when the wind stirs, that mirror fractures into countless shifting planes, scattering sunlight into flickers that dance and disappear. To watch the sea in sunlight is to see light learning to move. In the air above, droplets perform their own quiet miracles. A single sphere of rainwater acts as both prism and mirror, bending sunlight as it enters, reflecting it inside, then bending it again as it leaves. The result is the arc of a rainbow colors sorted by wavelength, stretched across the sky in order so precise it seems deliberate. Red bends the least, blue the most, so they fan apart into a spectrum that exists only for an observer standing at just the right angle between sun and rain. No two people ever see the same rainbow. Each one is a personal arrangement of light, recreated anew for every pair of eyes. Sometimes, high in the atmosphere, ice crystals take the place of raindrops, turning the sky into a cathedral of halos. When sunlight or moonlight passes through their hexagonal shapes, it refracts into rings, pillars, or arcs of ghostly color. These halos have names: sundogs, parhelia, circumzenithal arcs, but they all belong to the same family of illusions born from light refracted by frozen water. Even the faintest halo can make the sky feel sacred, as though something vast and unseen were revealing its edges for a moment before dissolving again. Underwater, light behaves differently still. The deeper you descend, the more it fractures into beams, columns, and threads. Sunlight filters down in shafts that sway with the waves, painting the sand in patterns of gold and silver that ripple like breathing. Fish flash in and out of these corridors, their scales catching what little color remains. To dive into this world is to step into a slow, glowing dream, where light has learned to move like water, bending and weaving with every current. In every droplet, every mist, every wave crest, light meets its match. It cannot pass unchanged. It must adapt, yielding its straight-line certainty to water's softness. The two are opposites, one weightless, the other heavy, one invisible, the other revealing. Yet together they make the world visible. Without water, there would be no reflections, no color in the sky, no rainbows after storms. Without light, the ocean would be a black silence, unseen and unknowable. Even a single tear carries this dialogue within it. When light strikes its curve, it refracts, bends, glimmers. It reflects the world back in miniature, showing both the watcher and what they see the same. Physics that paints the horizon blue lives in that small, shimmering drop. Every reflection, every flash of brightness, every glint of sunlight on a wave is a reminder of how the universe plays with perception. How something as small as a molecule of water can bend something as vast as light into beauty. The next time you see the ocean shimmer or a rainbow stretch across a storm-cleared sky, remember that you are witnessing an ancient collaboration. Light travels for 8 minutes from the sun to reach Earth, and in an instant, water transforms it, scatters it, softens it, turns it into color. It's a meeting of opposites that began before life existed, a partnership that still writes beauty across the world. Through every droplet and every wave, the universe continues its quiet experiment to show that even in the simplest collision of elements, wonder can be born. Every storm begins with heat, not fire, but invisible warmth rising from the sea, drawn upward by sunlight that has spent all day soaking into the surface of the water. The ocean exhales moisture into the sky, and what was once calm air begins to stir. Each molecule of vapor carries hidden energy, a kind of tension waiting to be released. When that vapor cools and condenses into cloud, it gives that energy back to the atmosphere. The sky responds by lifting faster, swirling harder, feeding on its own motion. From that exchange warmth into motion, vapor into wind, a storm is born. The process is almost delicate at first. Warm, moist air rises from the surface, expanding as it ascends, cooling until it can no longer hold all the water it carries. Droplets form tiny, glimmering spheres of condensation, and as they appear, they release latent heat. This released energy warms the air around them, making it rise faster, drawing in more moisture from below. The cycle repeats again and again, a self-reinforcing spiral of rising vapor and condensing cloud. What begins as humidity and breeze becomes a living engine, one that grows by devouring the difference between warmth and cold, between sea and sky. Over the tropics, where the ocean's skin glows with heat, these engines can grow immense. When conditions align enough humidity, a calm upper atmosphere, a Coriolis twist from the spinning earth, the rising columns of air begin to curve. They organize themselves into a spiral, each gust feeding the next, until the entire storm begins to rotate. This is the seed of a hurricane, a cathedral of vapor and wind built entirely from imbalance. Within it, air rushes upward in towering clouds, while the surrounding atmosphere collapses inward to fill the void. In the center, where everything converges, something strange happens. Calm. The eye forms, clear and quiet, surrounded by walls of thunder that climb 15 kilometers high. Inside those walls, the chemistry of storms becomes an orchestra. Every droplet that condenses releases a spark of warmth. Every spark fuels another surge of air, tightening the spiral. The storm's winds strengthen, feeding on temperature differences between ocean and atmosphere, until they roar across the water with unimaginable force. Yet despite their violence, hurricanes remain exquisitely structured. The heat engine inside them is almost perfect. Moist air rises, cools, condenses, releases energy, and the process begins anew. Nature's chaos, governed by equations so precise that meteorologists can predict its pulse, but never quite its heart. In monsoon systems, the rhythm is slower, but no less powerful. Over months, continents heat beneath relentless sun, while oceans remain cool and steady. Air over land becomes hot and light, drawing in moist air from the sea. As it climbs, condensation fills the skies with colossal clouds. The first rains fall in torrents, soaking the dust, feeding the rivers, turning plains into shimmering mirrors of water. Entire cultures live by this breathing of the planet. Months of dryness, followed by sudden abundance. Each drop that falls carries the weight of heat that once rose from the ocean, transformed into nourishment. The chemistry is simple, its consequence vast. At the smallest scale, the creation of a raindrop mirrors the formation of a storm. A particle of dust or salt floats in moist air. Water vapor clings to it, forming a thin film that thickens as more molecules attach. When the droplet becomes heavy enough, it begins to fall, collecting others as it descends. Every droplet in a storm has its own history, a journey from vapor to liquid, from sky to earth. Millions of them fall together, merging into sheets of rain that blur the boundaries between air and sea, between what is sky and what is water. Lightning crackles within these clouds, born from the same motion that drives the rain. As droplets and ice crystals collide, they exchange charges, separating positive and negative layers within the cloud. The imbalance grows until it breaks, sending a bolt of plasma through the air, heating it to tens of thousands of degrees in an instant. The thunder that follows is not just sound, it's pressure made audible, the atmosphere reshaping itself after a moment of perfect imbalance. Even in destruction, storms release their energy beautifully, in flashes that illuminate both the chaos and the order within. From space, a hurricane looks like a work of art. Its spiral arms stretch for hundreds of miles, clouds layered in perfect symmetry around a still, dark eye. It moves slowly, deliberate, and graceful, yet inside its calm geometry lie winds strong enough to level cities. It is the purest expression of thermodynamics made visible energy, transferring from warm sea to cold sky, from vapor to motion, from invisible heat to visible fury. And yet, when the storm passes, the world it leaves behind feels strangely alive. The air smells electric, the earth breathes steam, rivers swell and replenish the soil. What looked like chaos from above is, in truth, renewal from within. Every drop that fell, every gust that blew, was part of a process older than mountains and oceans, a conversation between heat and water, sky and earth. Storms remind us that creation often comes disguised as destruction. They are not mistakes in nature's order. but demonstrations of its precision. The same chemistry that forms a hurricane fuels the rains that feed forests, fills the aquifers that sustain life, and balances the temperature of the world. Heat becomes motion, motion becomes cloud, cloud becomes rain, and rain becomes calm. What seems wild and unpredictable is, beneath it all, the universe practicing balance through the artistry of water. Deep within the polar ice, the past is still breathing. Layer by layer, snow has fallen for hundreds of thousands of years, compacting under its own weight until it turned to ice, each season sealed beneath the next, each flake trapping a trace of the air that once drifted through the sky. Those layers are more than frozen water. They are the memory of the earth itself, a library written in crystal, where every trapped bubble and dust grain records the world as it was long before we were here to measure it. When scientists drill into the ice, their cores emerge like translucent scrolls. Some are no thicker than a tree trunk, others stretch for kilometers, drawn carefully from the heart of Antarctica or Greenland. Each layer holds a year, or sometimes just a season, compressed so slowly that a single meter can contain 1,000 winters. Within those layers lie tiny air pockets, perfectly preserved samples of ancient atmosphere. By studying the ratio of gases trapped inside, we can know how much carbon dioxide filled the air 10,000, 50,000, even 800,000 years ago. Each bubble is a breath exhaled by a forest, an ocean, a volcano, or perhaps by something long vanished. The ice does more than capture the composition of the air it preserves. Stories of catastrophe and calm. Traces of volcanic ash reveal eruptions that darkened the skies. Shifts in the isotopes of oxygen and hydrogen show how warm or cold the planet was when each layer froze. Flecks of pollen mark the spread of forests across continents, while microscopic soot records fires that burned before humans ever struck a spark. In one column of frozen light, we can see the Earth inhale and exhale through cycles of ice ages and interglacial warmth. It is humbling to realize that the snow falling today may someday tell future beings what this century felt like. When a core is sliced open in a laboratory, the air that escapes is ancient. Scientists describe it as the faintest sigh, a whisper of a world that no longer exists. In those samples, they can detect the rhythm of time itself, the steady rise and fall of greenhouse gases, the heartbeat of the planet responding to the tilt of its axis, the pulse of volcanoes and sunspots. Patterns emerge like music, showing how the Earth breathes in cold and exhales in warmth, how delicate the balance truly is. In that frozen memory, the present finds its reflection. Some of the most striking discoveries from these ice archives come not from the depths, but from the details. The thickness of a layer, the trace of a storm. A dustier band might mean a time when winds scoured the continents dry. A sudden spike in acidity could signal a massive eruption that cooled the globe for years. There are even layers tinted faintly with the residues of cosmic dust, reminders that meteors, too, once brushed the atmosphere. Every mark is a note in the long composition of climate, and taken together they form a record more complete than any written history. In the quiet darkness of the polar plateau, where temperatures never rise above freezing and winds sweep endlessly across the horizon, these memories remain untouched. The ice sheets hold within them not only evidence of ancient skies, but also a warning written in chemistry. They show how quickly balance can shift, how minor changes in temperature or carbon can ripple through millennia. When scientists compare the trapped air of today's atmosphere with the bubbles of the past, the difference is unmistakable. In a geological instant, the rhythm has quickened. The planet's breath is shorter, warmer, more urgent. But beyond the science, there is something poetic about it. The idea that water can remember. Each snowflake that fell, perhaps in silence beneath an aurora or in the soft darkness of a polar night, carried with it a moment in time. Over centuries, those moments layered themselves into eternity. When a core is drawn up, the drill hums through years stacked like pages, through ice that fell when mammoths roamed, through the winters that buried their bones, through ages when continents were still recovering from glaciers that sculpted the land we now call home. The ice does not speak in words. It speaks in ratios, densities, and faint traces of ancient air. Yet if we listen carefully, it tells us of patience, of cycles, of endurance. It reminds us that the earth remembers everything: the storms, the droughts, the eruptions, the calm between. It is easy to think of ice as something lifeless, but inside it hums the slow record of time, preserved with a precision no storyteller could match. And as that ice melts, the memory begins to fade. The bubbles that have survived for 1,000,000 years break and vanish, releasing the past back into the air it once came from. It is a quiet unspooling of history, an erasure that no one can stop. Yet even as it disappears, the lesson remains clear. The world does not forget. It holds our every breath, every fire, every season within its chemistry. The memory in ice is the mirror of our shared existence, fragile, intricate, and impossibly long-lived, whispering across ages that we are only the newest line in an ancient, ongoing story. Beneath the surface of the world, beyond the reach of sunlight and the chatter of rivers, there moves a different kind of water, one that never glitters, never roars, never breaks into waves. It travels quietly through sand and stone, winding through layers of earth laid down over millions of years. This is groundwater, the planet's hidden bloodstream, connecting mountaintops to valleys, deserts to deltas, roots to rivers. While the oceans breathe with the tides and the clouds wander freely through the sky, this water keeps its secrets in silence, moving in darkness through channels no one ever sees. The journey begins where rain meets earth. Each drop that falls onto soil is a choice between paths. Some runs downhill to join streams, some evaporates back into the air, but a fraction lingers, seeping deeper, drawn by gravity through the pores and cracks of the ground. As it descends, the world around it changes. Air vanishes from the spaces between grains, pressure increases, and the faint taste of minerals begins to fill the water. In time, those drops gather into underground reservoirs, vast, slow-moving seas that rest between layers of rock. These aquifers can be as shallow as a garden well, or as deep as the roots of mountains, storing water that may not see daylight again for centuries. Within them, water does not flow as it does in rivers. It seeps, it drifts, guided by gradients so subtle they are almost imperceptible. A single drop may move only a few centimeters in a day. Yet over thousands of years, this hidden network connects entire continents. Groundwater beneath a forest may one day emerge at a spring miles away or feed a stream that runs to the ocean. In this way, the world's hydrology forms one continuous pulse, rainfall sinking into soil, merging underground, re-emerging as rivers, and returning at last to the sea. Every mountain, every plain, every coastline is tied together by this unseen motion. The rocks themselves shape the flow. In regions of limestone, water dissolves the stone as it moves, carving caverns and tunnels that become underground rivers. These rivers can rush with the power of surface streams, echoing through darkness, unseen but alive. In karst landscapes, where the ceiling of these caverns collapses, sinkholes form gateways into the world below. Divers who venture into such places describe an alien realm, crystal-clear chambers stretching for miles, stalactites hanging above, silent currents winding through spaces that have never felt the warmth of sun. To swim there is to move through the veins of the earth itself. Some aquifers are ancient, filled with fossil water that fell as rain tens of thousands of years ago, when the planet's climate was colder and the ice sheets reached farther south. That water has been sealed underground ever since, trapped beneath layers of rock that protect it from evaporation and change. When humans tap these reserves through wells and pumps, They are drawing, not from a renewable cycle, but from deep time, from rainfall that fell before civilization began. The Ogallala Aquifer beneath the Great Plains, for example, holds water older than any city on the continent. It sustains farms, towns, and millions of lives, yet in many places it is being emptied faster than it can refill. Once gone, it will take thousands of years to return. Groundwater does not move alone. As it flows, it carries the chemistry of the land with it. Minerals dissolve into its passage, giving it flavor and hardness, feeding plants from below. The calcium in coral reefs, the salt in the sea, even the nutrients that rise through soil, all have passed through this hidden network at some point in their journey. In this sense, the earth drinks and exhales through the same substance, cycling the essence of rock and life together. When you taste water drawn from a deep well, you are drinking the memory of mountains. At the edges where groundwater meets the surface, springs appear clear windows into the unseen. Some bubble gently, cold and steady, while others burst forth warm with the heat of the planet's core. Many of the world's rivers are born from these hidden openings, their flow sustained through drought and season by the slow persistence of aquifers below. In deserts, an oasis is not a miracle of chance, but the work of this underground hand, guiding water through impossible distances to emerge where it's least expected. The life that gathers there, palms, reeds, birds, even people, is simply following the whisper of that buried current. If the oceans are the heart of the planet's water, then aquifers are its lungs. They breathe slowly, inhaling rain and exhaling springs, balancing the rhythms of surface and sky. But like lungs, they are vulnerable. When poisoned by chemicals, overdrawn by thirst, or sealed beneath concrete, their rhythm falters. The water that once connected everything begins to vanish, leaving silence in its place. To lose an aquifer is to lose a piece of the earth's memory, a voice that speaks only in flow. Still, even in places where the land seems parched, the water moves below, quietly patient. It does not rush. It does not protest. It simply waits, following gravity's slow command, carrying with it the story of where it has been and where it will go. Every droplet underground is part of an endless pilgrimage, one that began when the first rains fell and will continue long after our cities have crumbled. The surface world may change with every storm, but beneath our feet, the ancient water keeps its steady rhythm, connecting all things through silence, depth, and time. The balance of water on Earth has always been delicate. For billions of years, it has cycled between ocean and sky, ice and vapor, river and rain, maintaining the quiet equilibrium that makes life possible. That balance is not static. It sways and shifts like breath, rising and falling through ages of heat and cold. But now, that rhythm has begun to quicken. The pulse of water, once steady and self-correcting, is faltering under the weight of our warmth, our consumption, and our forgetting. The systems that once seemed eternal are revealing how fragile they truly are. High in the mountains, glaciers, the frozen hearts of ancient storms are retreating. Each year they grow thinner, their edges shrinking back toward the peaks that once sheltered them. For centuries they have been the world's reservoirs, locking away winter's snow and releasing it slowly as meltwater through the long, dry seasons. Entire civilizations were built around their generosity. Now, as the air warms, they give too much too soon. Rivers swell briefly in spring, flooding fields and valleys, but by summer, the flow weakens, the rhythm breaks. What was once a dependable heartbeat of melt and renewal has become a surge followed by silence. In the Arctic and Antarctic, ice that has lasted for millennia fractures and drifts apart. Sheets of frozen ocean, so vast they reflect sunlight back into space, are thinning until they vanish each summer, exposing dark water that absorbs more heat. The feedback is relentless. Less ice means more warmth means less ice. Beneath the surface, permafrost softens, releasing ancient methane and carbon once locked safely away. The chemistry of the air shifts, and the planet inhales its own fever. But it is not only the poles that are changing. Far to the south, monsoon patterns that once followed predictable cycles now stagger and stall. In some years, the rains arrive late, parching fields and emptying reservoirs. In others, they come all at once, falling too fast for the ground to absorb, washing away soil and seed alike. The same instability ripples through oceans, where the great currents that move heat around the globe are beginning to drift from their ancient paths. These invisible rivers, the Gulf Stream in the Atlantic, the H. Kuroshio in the Pacific, carry warmth from equator to pole, balancing climates, shaping winds, guiding migrations. They are driven by differences in temperature and salinity, by the sinking of cold, dense water and the rising of warm, light currents. But as polar ice melts and fresh water floods into the sea, that density weakens. The engine slows, and when it slows, everything it touches begins to shift. A change in these global currents doesn't just alter weather, it rewrites the patterns of life. Warm waters may no longer reach the same coasts. Fisheries collapse, coral reefs bleach, and storm tracks bend into new territories. The air itself grows unpredictable. Droughts stretch longer across continents, and once temperate regions taste the edge of extremes. Where glaciers once fed rivers, dust now drifts. Where lakes once mirrored the sky, salt flats spread like scars. Meanwhile, beneath the ground, aquifers are being drained faster than they can refill. Wells that have supplied generations run dry, and the land above them begins to sink. The invisible balance that ties rain to rivers and rivers to seas depends on patience, the slow seep of water through soil, the gradual percolation of time. But impatience is the mark of our age. We have learned to pull more than the system can give, to take from the deep what should remain for centuries to come. And yet, even now, the cycle still holds fragments of resilience. The same water that evaporates from a warming ocean will one day fall as rain on a distant field. The same ice that melts from a glacier will flow into a river and nourish life downstream. The system tries to heal itself, as it always has, through movement. Water does not disappear. It changes form, searching for new equilibrium. But balance is not guaranteed. When one part of the cycle falters, the rest must strain to compensate, and the harmony grows harder to sustain. The earth has endured vast transformations before. It has frozen, solid and burned with volcanic fire, its seas rising and falling with the slow pulse of time. But the speed of change now is something new. The scale is human. We are reshaping the cycle that shapes us, bending it toward an unknown end. The melting of glaciers, the drying of aquifers, the shifting of currents, they are not isolated events, but verses of the same story. They tell us that the planet's water, once balanced by nature alone, is now entwined with our every decision. If there is fragility in this balance, there is also grace. The same laws that govern collapse also allow renewal. A forest regrows after fire, a river clears after flood, a lake returns after drought. The planet does not resist change, it transforms through it. What it cannot survive, however, is silence, the refusal to notice the shift until the rhythm is gone. The fragile balance of water is not just a matter of physics or chemistry. It is the memory of the world, learning to keep itself alive. Every drop that falls, every current that moves, every glacier that melts, is part of the same ongoing act of preservation. To lose that balance is to lose the language by which the earth speaks to itself. And so, the question that remains is not whether water will endure, it always will, but whether we will learn, in time, how to move gently enough for it to continue its song. Water is the planet's most patient artist. It does not hammer or carve in bursts of violence, but shapes the world through persistence, drop by drop, tide by tide, century by century. Where it moves, it alters. Where it lingers, it builds. To watch water at work is to witness the slow choreography of creation, the way something so soft can sculpt stone, rearrange continents, and design entire landscapes simply by obeying gravity and time. A single raindrop landing on bare rock seems harmless, almost tender. Yet multiplied over millennia, those drops wear away mountain faces, carrying with them grains of dust that become the sediment of valleys far below. Streams form, then rivers, each one finding the easiest path through resistance, eroding as they go. Every bend in a river tells the story of compromise, a constant negotiation between motion and obstacle. Where water flows fastest, it cuts deep. Where it slows, it deposits. Together, those contrasts carve out canyons that take thousands of years to form and millions more to perfect. The Grand Canyon, for all its grandeur, is nothing more than the memory of a river called the Colorado, its course written into layers of time and stone. Beneath the surface, water continues its artistry in the dark. Rain that seeps through soil becomes acidic as it mingles with carbon dioxide from the air and the roots of plants. Over time, this faintly corrosive water encounters limestone and begins to dissolve it, molecule by molecule, widening cracks into tunnels, tunnels into caverns. These spaces grow quietly, unseen, until they open into great chambers filled with the slow architecture of stalactites and stalagmites. Each drop that falls from the cave's ceiling carries a trace of dissolved stone. As it evaporates, it leaves behind a ring of mineral. Thousands of years of repetition form pillars and curtains of rock so delicate they seem almost alive. Standing inside such a cavern feels like walking through the lungs of the earth, where water has sculpted breath into form. At the edges of continents, water becomes a painter. Waves crash and retreat in endless rhythm, each one brushing the shoreline with foam and grit. The force of their repetition grinds cliffs into sand, sculpting arches, sea stacks, and coves. Coastlines are never finished. They are canvases in progress, reworked daily by wind and tide. What looks permanent in one lifetime is, in the scale of the ocean, fleeting. A single storm can redraw the boundary between land and sea, erasing one shape and revealing another. To the waves, creation and destruction are the same act. Rivers, too, are both sculptors and builders. They wear down mountains, yet they also construct deltas, layering silt where they meet the sea. In those muddy fringes between fresh and salt water, new land emerges grain by grain, forming marshes and islands alive with plants and birds. Each flood reshapes these landscapes, sweeping away what was and depositing what will be. From above, a river's delta looks like a hand reaching out to the ocean, a reminder that the planet's architecture is not drawn in lines but in motion. Glaciers perform the same work on a grander scale. They are rivers slowed to stone, flowing so gradually that a human lifetime barely registers their movement. Yet their power is immense. As they advance, they grind mountains into valleys, dragging boulders like sandpaper across the Earth's surface. When they retreat, they leave behind U-shaped valleys, scattered lakes, and moraines of rock monuments to their passage. Even now, long mying, after the last great ice age, the fingerprints of glaciers are visible everywhere, in the fjords of Norway, the Great Lakes of North America, the smooth stones that line ancient riverbeds. Water does not create chaos. It seeks balance. Every curve in a coastline, every hollow in a canyon is an expression of equilibrium found through motion. When it floods, it redistributes. When it evaporates, it returns. Even the seemingly destructive act of erosion is a way of restoring harmony between weight, flow, and resistance. Over time, landscapes evolve toward efficiency, guided not by intention but by the quiet logic of fluid mechanics. The artistry lies in that balance, the way beauty emerges naturally from the pursuit of equilibrium. And yet, For all its patience, water also knows force. It can cut through granite with the persistence of a thought, yet in moments of fury it reshapes the world in an instant. Tsunamis, flash floods, and torrential storms remind us that the same element, capable of nurturing life, also holds the power to erase it. But even in violence, its purpose is the same: to move, to equalize, to continue the endless exchange between solid and liquid, stillness and motion. If you look closely enough, every stone tells the story of its encounter with water. The smoothness of a pebble, the curve of a cliff, the glint of a crystal, all are signatures of its touch. Even deserts bear the memory of vanished rivers, their dry channels still tracing paths that once shimmered with flow. Water's art does not demand permanence, it thrives in impermanence. Its masterpieces are living landscapes, changing as they are created. In the end, water shapes more than the land, it shapes perception. It teaches that strength is not in resistance but in persistence, that creation need not be sudden to be profound. The canyons and caves, the coastlines and deltas are reminders that the world is sculpted by motion too slow for us to see. Every drop, every tide, every trickle of meltwater is part of the same grand composition. And though we may walk upon the finished forms, we are always moving through a work still in progress, one that water continues to carve with unending patience and grace. Every civilization begins with the search for water. Long before the first cities, before written words or carved symbols, people followed rivers and springs, carrying their hopes along with their tools. Where water flowed, life gathered. Villages grew beside it, fields unfurled under its reach, and stories began to take shape in its reflection. Water was not only a resource, it was destiny. To find it was to live, to lose it was to vanish. Across every continent, the arc of human history has been written in its currents. The earliest cities were born from rivers that rose and fell like breath. In Mesopotamia, the Tigris and Euphrates carved ribbons of fertility through an otherwise harsh plain. People learned to tame their floods with canals, dikes, and reservoirs, transforming chaos into rhythm. Those first irrigation systems were feats of quiet genius, channels dug by hand that turned the desert green. With water came grain, with grain came surplus, and with surplus came cities, temples, laws. Civilization itself was a consequence of water made predictable. But even then, the rivers reminded their makers who held the power. Too little rain brought famine, too much, and entire harvests drowned. The same forces that nourished could destroy overnight. Farther east, along the Nile, Egyptians built their world on the pulse of a single river. Each year the waters rose, spreading silt across the floodplain and renewing the soil. Farmers watched the horizon for the first sign of swelling and built calendars around its rhythm. The Nile was their god, their clock, their mirror of eternity. They measured its depth with stone columns and recorded its moods in hieroglyphs. When it failed to rise, they prayed. When it overflowed, they rejoiced. To them, eternity was not stillness, but a cycle, a truth water itself embodied. In the valleys of the Indus and the Yellow River, similar stories unfolded. The Indus civilization engineered wells, baths, and drainage long before Rome dreamed of aqueducts. The Chinese learned to bend their unpredictable river with levees and channels, turning floods into sustenance. Each culture adapted to its water, shaping its architecture, its religion, even its language around the movement of rivers. The words for life and water often shared the same roots, as if the two were inseparable ideas, and they were. As cities expanded, water became not only a gift but a challenge of scale. Rome rose on aqueducts that carried spring water across mountains, feeding fountains and public baths that became symbols of power and purity. The empire's engineers turned water into a form of order, straight lines of stone channeling nature into obedience. Yet when Rome fell, many of those aqueducts crumbled, and with them went the sanitation and health that had defined its urban life. The ruins still stand today, arches reaching across valleys like empty veins, reminders of how fragile mastery can be when it depends on unending maintenance. Elsewhere, entire civilizations disappeared when their relationship with water shifted. In the Yucatan, the Maya built great cities around cenotes, natural wells that opened into the groundwater below. They honored these pools as portals to the underworld, sacred bridges between life and death. But centuries of drought fractured their delicate balance. As rainfall waned, crops failed, and the jungle slowly reclaimed their temples. In Mesopotamia, salinization from irrigation poisoned the soil over generations, turning once rich farmland into barren earth. Control became overuse, and the gift of water turned to burden. Through the Middle Ages and beyond, humanity continued to follow its flow. Cities clustered along trade, rivers, the Thames, the Seine, the Danube, each one a lifeline of commerce and survival. Wells became communal gathering places where stories and rumors were drawn up with the buckets. The act of drawing water was itself a ritual, one that tied people to the land, to each other, to time. Water was never just something to drink, it was something to live by. Then came the age of machinery, and the ancient relationship changed again. Steam engines boiled it, turbines captured it, pipes confined it. Water became infrastructure, measured in cubic meters and megawatts. Cities no longer grew beside rivers, but above them, diverting their flow through underground arteries. Reservoirs flooded valleys to slake the thirst of distant metropolises. The old reverence turned to reliance, and reliance to assumption. We forgot that mastery was only ever temporary. Yet even now, the human story is still bound to it. Wars have been fought over access to rivers. Borders have shifted with the migration of water tables. Nations measure their futures by the snowmelt on distant peaks. We build dams to hold it back, but in doing so, we trap the sediment that once renewed the soil. We drain aquifers that took millennia to fill. We have learned to summon water at will, but we have not learned to listen when it changes its mind. Every well, every pipe, every rain barrel is a modern echo of the first moment someone cupped their hands to drink from a stream and saw their reflection ripple across its surface. That reflection has always been a kind of truth, the awareness that water sustains not just our bodies, but our continuity. Without it, cities become ruins. With it, deserts bloom. It is the great equalizer, humbling empires and nourishing children in the same gesture. Water has never belonged to us. We borrow it, shape it, follow it, and sometimes lose it. Our civilizations are temporary interruptions in its flow, brief pauses in a story much older than our names. When the wells run dry or the rivers rise beyond control, we are reminded of what the ancients already knew, that every triumph of humankind depends on something that can slip through fingers in an instant. The mastery of water was never about control. It was, and always will be, about respect, the quiet understanding that we live only as long as it continues to move. The future of humanity will be written in water, just as its past has been. For all our machines and satellites, our data and inventions, we remain tethered to that simple molecule of hydrogen and oxygen. It shapes our climate, fuels our bodies, and defines the borders of what life can endure. But as the world grows warmer and more crowded, the ancient balance that sustained us begins to shift. Rivers no longer reach the sea, glaciers retreat into memory, and salt creeps inland where fresh water once ran. The challenge that lies ahead is not only how to find more water, but how to learn from it again, how to live with it, not merely extract from it. In coastal cities where rainfall grows erratic and aquifers fail, the answer may come from the sea itself. Desalination plants now hum along the edges of deserts, turning salt water into something drinkable, drop by drop. It is a kind of modern alchemy, boiling, filtering, and forcing water through membranes fine enough to catch single ions. The process is energy-hungry, expensive, and imperfect, but it keeps life moving where nature no longer does. The water it creates is sterile, stripped of minerals and memory, yet it sustains millions who would otherwise go without. As technology improves, new methods promise to make desalination gentler using sunlight instead of fossil fuels, or graphene filters that let water pass while salt stays behind. These machines are the new wells of civilization, their pipes reaching not into the earth but into the deep, endless ocean. At the same time, humanity has begun to look beyond Earth itself for answers. Locked within the polar ice caps of Mars and the moons of Jupiter and Saturn lies a treasure that has nothing to do with gold. Ice is the currency of possibility, a promise that where water exists, life might also take root. On Mars, orbiters have mapped buried glaciers and traces of ancient riverbeds winding through its rust-red plains. Rovers have tasted the frost and confirmed what long-distance telescopes only guessed, that the planet's past was once blue. Scientists dream of tapping those frozen reserves one day, melting them into air, into soil, into breath. For future explorers, water will be more than sustenance. It will be fuel. Hydrogen for rockets, oxygen for domes, the foundation of self-sufficiency on another world. But before we learn to harvest the ice of Mars, we must confront what is melting here at home. The cryosphere, the frozen layer of glaciers and polar caps that reflects sunlight and regulates temperature, is unraveling faster than our models predicted. As it melts, it reveals not only ancient air and sediments, but a glimpse of our own vulnerability. The oceans rise, swallowing the edges of cities, while storms grow stronger and seasons blur. What was once distant and theoretical is becoming personal, visible in flooded streets and disappearing coastlines. The future of the blue planet depends on how quickly we can restore balance to the systems that govern water's endless motion. Some imagine solutions that sound like science fiction. Giant mirrors in orbit to cool the poles. Machines that capture humidity from the air and condense it into drinking water. Pipelines that move rivers across nations, carrying the excess of one region to the thirst of another. Icebergs towed from Antarctica to the Gulf. Clouds seeded to wring rain from reluctant skies. Each idea reflects our instinct to engineer our way out of scarcity. Yet beneath that ambition lies a quieter truth. Every new method of control carries its own price. Desalination leaves, salt brine behind. Cloud seeding alters ecosystems unseen. Even ice mining on other worlds raises the same question that has followed us since the first irrigation ditch. How much can we take before balance breaks again? Still, hope persists in the ingenuity that water itself inspires. New discoveries show how nature already manages what we struggle to imitate. Plants that pull moisture from the air in the driest deserts. Fungi that store it underground. Materials that mimic the wings of beetles or the skin of cacti, collecting droplets from fog and dew. We are learning that survival will come not from domination, but from imitation, by following water's own logic of flow, adaptation, and renewal. The next age of exploration will not be defined solely by the places we reach, but by the ways we learn to sustain them. Whether on Mars or in the depths of our own oceans, the search for water is a search for continuity, for the thread that binds every form of life to every other. It is both a necessity and a teacher, reminding us that scarcity is not new, only forgotten, and that resilience often lies in simplicity. Someday, when future generations look back, they may see this era as the turning point to the moment we finally understood that the planet's water is not just a resource to be consumed, but a relationship to be mended. The oceans, the rivers, the frozen reservoirs beneath alien skies, they are all part of the same story, one that began long before us and will continue long after. Whether that story remains blue or fades to dust depends not on what we discover, but but on what we remember. Because the future, like the past, will always belong to water and to those who learn how to listen when it speaks. Every person carries a river inside them. It winds quietly beneath thought and language, a current older than memory itself. From the moment we are born, surrounded by the warm tide of the womb, we are creatures of water drawn to it, shaped by it, haunted by its endless motion. Perhaps that is why no sound soothes us like the rhythm of waves or the hush of rain. Somewhere deep within, the body recognizes its origin, and the mind remembers what it cannot name. To stand at the edge of water is to feel something ancient stir. The horizon ripples, light shifts, and for a moment, the line between self and world dissolves. Oceans and rivers invite reflection not only because they mirror the sky, but because they mirror us. Our emotions follow their patterns, the rush of joy like a flood, the pull of sorrow like a slow receding tide. Even our language reveals the kinship. We speak of waves of grief, depths of despair, streams of consciousness. Water is the shape emotion takes when it moves through matter. Across every culture, water has always been sacred. It cleanses, heals, baptizes, renews. It erases what came before and makes room for what might come after. The act of washing, of submerging one's body in a river or pouring a handful of cool water across the skin is a ritual of return, a quiet acknowledgement that everything eventually flows back to source. In myths and faiths around the world, gods and spirits dwell in wells, springs, and seas. The Greeks imagined the river Styx as the passage between life and death. The Hindus call the Ganges a living goddess who carries the souls of the departed. In every tradition, water is not just a symbol of purity, but of transformation, a reminder that change itself is holy. Even dreams understand this truth. When we dream of water, it almost never sits still. It floods, drifts, crashes, or rises, reflecting the movements of the subconscious. Psychologists once said that dreaming of the ocean meant confronting the unknown self, the vast, unfathomable parts of who we are. And maybe they were right. Water hides its depths, just as we do. What looks calm from the surface can hold invisible currents below, powerful enough to pull down anything unanchored. To dream of water is to meet the part of yourself that resists containment, that remembers freedom and fears surrender. But our relationship with water is not only spiritual, it is visceral. It calls to our senses. The taste of salt, the shimmer of light on a river's bend, the scent of wet earth after rain, all these things reach us before words do. They bypass logic, traveling directly into memory. Scientists have found that the human body reacts to the sound of flowing water with lowered blood pressure, slower breath, the easing of muscle tension. It is as if, hearing it, we instinctively prepare to rest. Somewhere in the long evolution of our species, we learned that where water flowed, life was near, and safety followed. That lesson never left us. Still, there is another side to this connection. For as much as we are drawn to water, we also fear it. The ocean's vastness reminds us of scale, of how small we truly are. Floods and storms strip away the illusion of control, returning us to the humility of our beginnings. The same element that nourishes can also consume. The sea does not hate or love. It simply moves according to its laws, indifferent to the fragile boundaries of human will. And perhaps that, too, is part of its power, the way it teaches surrender. In water, we are weightless, helpless, and free all at once. Artists and poets have always understood this duality. Monet painted its shimmer, Turner its fury. Musicians try to capture its rhythm in sound, dancers its flow in motion. To depict water is to attempt to hold the unholdable, to translate movement into stillness without losing its soul. Even our technologies, the fountains we build, the glassy reflections of modern architecture speak to the same longing. We surround ourselves with water's likeness because it gives us a glimpse of impermanence made beautiful. In the end, what we seek in water is what we seek in ourselves: clarity, depth, reflection, renewal. We go to it when we need to think, when we need to grieve, when we need to feel small enough to see the world as vast again. Sitting beside a lake or standing in the surf, we become porous. The noise of thought dissolves, and what remains is the quiet rhythm of breath and wave, the reminder that all things move and return. The river within us flows toward the same destination as every river on earth, the sea. It gathers all that we have been, the storms, the stillness, the sediment of memory. It carves us as surely as water carves stone, shaping who we are through erosion and renewal. And when it finally reaches the vastness, it does not end. It becomes part of something larger, unbroken, and eternal. That is why we keep coming back to water's edge, not to conquer it or even to understand it, but to remember, to stand between the known and the infinite, to feel both fear and peace, and to hear, for just a moment, the quiet voice of the universe whispering through the tide. You were born of this, and you belong to it still.